The next concept is magnetization and magnetic intensity. And magnetic intensity. These two concepts are correlated to each other. So, if you take a solenoid or any interior of the solenoid, it contains two different magnetic fields, interior field, exterior field. The total magnetic field due to the solenoid is the sum of interior field plus exterior field. So, the total magnetic field is equal to M is equal to M net by unit volume. So, the magnetization is equal to capital M is equal to M net per unit volume. We know that magnetic field strength B is equal to mu naught Ni, where N is equal to number of turns per unit length, where I is equal to total current passing through it, where mu naught is the permeability. If this is the case, take a solenoid like this. If this is the turn, so if this is the case of the solenoid, if the interior of the solenoid is placed with a non-zero magnetic substance, then the magnetic field inside the solenoid will be greater than the B naught, which is actually B naught. So, the magnetization due to this non-zero magnetic field will be Bm. We can write this one as mu naught into M. So, we can write B is equal to B naught plus Bm. So, the total magnetic field is equal to interior plus exterior, or in the absence of the magnetic material plus in the presence of the magnetic material. So, B naught is equal to mu naught Ni. So, we can write Ni is equal to H. So, therefore, B naught is equal to mu naught H. So, mu naught H plus mu naught M. So, B is equal to B naught plus Bm. It is mu naught H plus mu naught M. So, we can write mu naught into H plus M. Now, we are going to derive the equation or importance between the H and B. So, B by mu naught is equal to H plus M. H is equal to B by mu naught minus M. This H is called magnetic intensity. So, the total magnetic field due to a solenoid or due to any material is explained in two ways, sum of magnetic intensity plus M. So, what is this H and what is this M? We are going to discuss now. So, the total magnetic field inside a sample is two types. One is due to the external factors. The magnetic field due to the external factors is represented by magnetic intensity, nothing but H. One is due to the specific nature of the material used. Due to the specific nature of the material used. This is represented by M, magnetization. So, magnetization is nothing but the magnetic field due to the specific nature of the material used. Magnetization intensity or H, magnetization intensity H is called as the magnetic field due to the external factors. These two are related like this. M is equal to chi H, where chi is called susceptibility. This susceptibility is one of the important terms to classify the magnetic materials. Now we are going to substitute this M is equal to chi H value in the given expression above in the previous one. We are going to find out this susceptibility values. So we know that M is equal to chi H. So B is equal to mu naught into H plus M. So we can write mu naught into H is H, M is equal to chi H. So if you take place mu naught H into 1 plus chi is equal to B. This chi is susceptibility. If this chi value is less than 0, means minus, negative values, means negative values. This will be diamagnetic substance. If this chi value is greater than 0, but small values, not the larger one, that is paramagnetic. Greater than 0, positive, but small scale, it is paramagnetic. If the same chi value greater than 0 means positive only, but in large scale means the values will be high, so high. In that case, that magnetic substance is ferromagnetic. Same chi is greater than 0, positive only, but large scale, larger magnitude, that is ferromagnetic. This is the classification of magnetic materials on the basis of chi value or susceptibility values. But how they will behave, what is their nature, we are going to discuss now. So we got B is equal to mu naught H into 1 plus chi. We can write mu R is equal to 1 plus chi. So B is equal to mu naught mu R into H. Mu naught into mu R is mu H. So we can understand that where in place of 1 plus gamma chi, we wrote mu R. So what is this one? Relative magnetic permeability. This relative magnetic permeability values really gives the explanation of the different magnetic materials. So mu naught into mu r into h, we wrote B is equal to mu h. So therefore mu is equal to B by h, and we can write B is proportional to h also. So the units and dimensions of the h are similar to the units and dimensions of B. So this relative magnetic permeability is analogous to dielectric constant in electrostatics. It is analogous to dielectric constant. Analogy with respect to the dielectric constant K. This is the problem which relates the BH mu naught. The content of the problem is the solenoid has a core of a material with relative permeability 400. So we should write the quantities. Relative permeability mu r is equal to 1 plus chi is equal to 400. The windings of the solenoid are insulated from the core and carry a current of 2 amperes. The current carried by the solenoid is 2 amperes. I is equal to 2 amperes. If the number of turns is 1000 per meter, therefore N is equal to 1000 per meter. Calculate A, H, B, M, C, B and magnetizing current IM. So we will find out one by one. So first bit is A, H is equal to Ni. So N is equal to 1000, I is equal to 2 amperes. So therefore H is equal to 2000 A per meter square. So H is equal to 1000 into 2 amperes, it is 2000 A per M. So the B bit M. So if you want to find out the B M, we should find out the B first. So the B value is mu r mu naught H. Mu r we have 400, mu naught 4 pi into 10 to the power of minus 7, H 2 into 10 cube. So this is 10 cube, 10 square, 10 power 5, 10 power 4 into 8, 8 into 4 pi, 32 pi into 10 to the power of minus 7, 32 into 3, it will be approximately 10. So you will get 1 Tesla. This is B value. So to find out the M value, so M is equal to chi H. So if you want to find out the M value is chi H, the chi is 400. So chi is equal to 1 minus mu r into H. So 1 minus mu r is 400. So mu r minus 1 is 399. H is 2 into 10 cube. 399 into 2, 798 into 10 cube. So we should find out the magnetizing current. The magnetizing current through the solenoid is nothing but the minimum amount of current which can pass through the solenoid under these magnetic fields. So it should be represented by B is equal to mu r n naught into I plus Im. So the current should cross over the core of the magnetic material to withstand with this magnetic field. So we know that mu r 400, n naught, n is equal to 1000 per meter, n naught is equal to 10. So I is equal to 2 amperes plus Im. B is equal to 1 Tesla. So from this we can write 2A plus Im is equal to 1 by 4000. So Im is equal to 1 by 4000 minus 2 amperes. So we will get 794 amperes. So almost 800 minus 2, like that we will get 794 amperes. So this much is the current which is needed to pass over the magnetizing current which is passes through the solenoid.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.